in triangles, the first statement and reason that you normally learn are that the interior angles of a triangle are supplementary. Interior angles are referring to the inside of a triangle. So those three angles, A, B, C, on the inside of the triangle add up to 180 degrees. So notice in this example, we have two different triangles. They look different, but their properties are the same. So I say angle A plus B plus C is equal to 180 degrees. And my reason is sum of angles in triangle. Notice that there wasn't a letter on the inside of this angle, so I'm using a capital letter A with a little cap on it to refer to angle A. So I'm using this vertex. So if you don't know what vertex means, is where two lines meet each other. So this point is called the vertex, and that angle then is formed between those two lines. So in order to use it correctly in geometry, when we don't have letters on the inside, for example, X, then I use angle A, capital A with a hat on, plus angle B, plus angle C, referring to the three different places where the lines meet. The next one is a bit harder to see. It reads, the exterior angle of a triangle is equal to the sum of the interior opposite angles. So let's start with the words exterior angle. That means or refers to the angle on the outside of a triangle. And again, here are two examples that look slightly different, but they have the same properties. It's important when we speak about the exterior angle, it's one of the sides of the triangle that's extended. So this line is a straight line. So these are straight lines. They're not running at a different angle. It's one of the sides of the triangle that is extended. Further on it says it's equal to the sum of the interior opposite angles. So interior means on the inside of the triangle, and opposite is on the other side. So here we can see that that's the exterior angles, and the angles X and Y on the other side of the triangle. In this example as well, theta is on the exterior and X and Y on the other side of that triangle. So now we have theta is equals to X plus Y, and the reason is exterior angle of triangle, EXT angle of triangle. Next up, we have the angles of opposite equal sides in an isosceles triangle are equal. So we are given information that the line AB is equal to the line AC in length. So in a diagram, lines through, not arrows, but lines through, tell me that those two sides are equal in length. And how we write it mathematically is that AB is equal to AC. Now what the statement is saying, that the angles opposite equal sides, so we have our equal sides, that those angles are equal in size. So this is called an isosceles triangle because it has two sides of the same length. That's an isosceles triangle. And that these two angles are equal. Now notice the reason. We don't say properties of isosceles. We say angles opposite equal sides. And if you would like, you can refer to the equal sides. It's not necessary to make this statement, but it shows your understanding if you do. But it's angles opposite equal sides. So this example is also referring to an isosceles triangle. Here we have the sides opposite equal angles in an isosceles triangle are equal. Now we are not given the information that AB is equal to AC. We are given angles that are equal in length. So we know that angle B is equal to angle C. And from this information, we can make the conclusion that the line AB is equal to the line AC. So AB is equal to AC, and now we are saying sides opposite equal angles, because angle B is equal to angle C. So if we compare that to the previous example, in the previous example, we were given the sides that are equal, and therefore we can conclude that the angles are equal, and we say angles opposite equal sides. And now we are given the angles are equal, and we say that the sides AB and AC are equal in length, therefore sides opposite equal angles. Next up, we have a right-angled triangle. So it reads, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The word right-angled triangle means that within this triangle, one of the angles are equal to 90 degrees. Then another word that we see here is hypotenuse. So the hypotenuse is referring to the side of the triangle that is opposite the 90-degree angle. And we are given that angle E is equals to 90 degrees, which is a right angle. So what that statement is saying is that DF, the hypotenuse, squared, so the length of DF is equal to the E squared plus EF squared. And this is called Pythagoras, or the theorem of Pythagoras, which you normally learn in grade 8 and then expand upon in grade 9. Now the next one we don't see as often in homework or in examinations or assignments, but it is an important one to remember, especially if you go to your higher grades, grade 10, 11, and 12. So it reads, if the square of the longest side in a triangle is equal to the sum of the other two sides squared, then the triangle is right angled. So if I have DF, which is the longest side of the triangle, and I square it, and I add DE squared and EF squared, if these are equal, so the hypotenuse squared equal to the two shorter sides squared in length, then DE is perpendicular to EF, or I can say that angle E is equal to 90 degrees. And I'm not using Pythagoras, I'm saying this is the converse of Pythagoras. I'm proving that the Pythagoras theorem exists in this diagram. So in the previous example, in order to use Pythagoras, you need a 90-degree angle. That information needs to be given. Then you say Pythagoras. But in this example, originally we were not given that the angle E is 90 degrees. We are proving that it is equal to 90 degrees. So then we say converse of Pythagoras. So I have proven the theorem of Pythagoras by using the lengths of the sides.